It's this one here?
Yeah.
Okay. So they want you to do this mentally. So, I mean, okay. So obviously the entire idea is zeros. There will be a part of the problem that might be harder or easier to do mentally. For example, part A, what's the immediate first thing you have to figure out? The zeros you forget about because you can always tack them on at the end. So what do you have to be able to do in your head? 58 times 5. You with me? So if you don't want to visualize in your head 58 times 5, carry the thing, what's another way we can do that? What's the greatest number besides 0 or 1 to multiply by? 10. Think about it. Do you agree with me? 10. Multiply by 10, what does that do? That's 0. So 58 times 5, do compensation. If you take a factor of 2 away from 58, what are you left with? Divide 58 by 2. 29. And you give it to the 5. So now it's 29 times 10, which is 290. And then you just throw all the extra zeros on the end of it, right? Because again, our number system is based on 10. So anything involving multiplying by 10 has to be easy because it matches with our number system. And they all basically boil down to that. You just have to remember what the hell that means. What does that mean? How many zeros would come after the 7? 5. That's all it means, right? It's just a nice, concise way. So if I had 81 followed by 40 zeros, I could just do 81 times 10 to the 40th, or 8.1 times 10 to the 41st, to make it more concise. Are you guys with me? Is that all right? Is that enough for that one? Because I think they all basically involve that. Okay. Anything else from homework before we look at some videos? Yes? Number, sorry? 20? 28. Well, this is good. Wait, where'd it go? There it is. 28. Oh, yeah, okay. So, the duplication algorithm for multiplication. Whoa. Combines a succession of doubling operations followed by addition. Okay. Yeah. So to compute 28 times 36, the 36 is repeatedly doubled as shown, right? And then, of course, it's continued on the next page. So they doubled it. The process stops when the power of 2 in the list is greater than the number by which we're multiplying. Here we want 28 of the 36s, and since 28 equals, oh my gosh, okay. 28 equals 60 plus 8 plus 4. The product of 27 equals 60 plus 8, blah, 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 blah. Okay, so very quickly, what did they calculate here? They ended up calculating 16, right? Times 36. And 28 is 16 plus, how did they break it up? 16 plus 8 plus 4. Is that okay by itself? We've done that before, but we didn't use these numbers, right? So if I wanted to do 32 times 90, couldn't I do 30 plus 2 times 90 and then distribute, correct? We've done that before. Is everybody with me? 32 times 90, right? 32 is 30 plus 2 and then distribute the 90 and then add those together, right? Cool? So there's a lot of other ways to kind of rewrite the number you're multiplying by. So if 28, let me go back here. 28 is 16 plus 8 plus 4. All right, let me see. Let me write this down. Yeah, thankfully, very nice people said, we won't come today, so you have less quizzes to grade. Oh, that's so nice. Now I also have more paper now. So if I do 28 times 36, I don't know, can you guys see that? No, I'm zoomed in way too much. By the way, real quick, This is obviously sort of a push you problem. So I was having a discussion in my pre-calc class today. There's homework problems that are like basic problems. Do you know how to do nuts and bolts? And there's homework problems that are like, all right, let's push you a little bit. So this is a push you problem, right? If you only have trouble with push you problems, you're doing pretty good. So then they said this is 16 plus 8 plus 4 times 36. Does everybody agree with me? And if you distribute, don't you get 16 times 36 plus 8 times 36 plus 4 times 36, correct? Aren't all of those in this list? Couldn't you just take that number plus that number plus that number? And then you're done. Now, is that easier than other things we've done? No. Is it another way, a valid method? Yes. So what's funny is, if you see a method in the homework that wasn't discussed in the section, it is a less traditional method. Do you understand? So the math involved is not difficult. The method isn't necessarily one we would do a lot. Does that make sense? Okay. Is that better? Is that better understood? So now all you've got to do, geez, that's a little bit loaded. All you've got to do is, like for this one, which one of them can you break up in powers of 2? Obviously the 62, right? So then you have to figure out 62 equals what power of 2 plus what power of 2 plus, right? You see what I'm saying? And then you just sort of create a list like they do. Just double, 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 double. Okay, maybe. So that problem, again, it's a very mathy problem. That is not a problem I would memorize the method. This is not something we use all the time, but it's definitely a method. It exists out there, and the math involved is not that crazy. Okay, maybe. All right. Anything else from homework stuff? Okay. Look. All right. So let's do this. Let's take a look at some videos. I'm not going to record them so that I don't get a copyright strike.